Everyone. This is the first of a three-part video on the product and quotient rule. And to follow along with this video, you can use the note sheet provided in OneNote called 2.4 Notes Product and Quotient Rule. So to get us started, we're going to do a quick little warm-up. So I'm going to ask you right away to pause this video and take a look at these four functions. Each of these cases, I want you to rewrite the function so that you are then able to use the power rule to take the derivative of this. Once you've done that, press play and we'll take a look at the results. Here are the results to your warm-up questions. And in each of these cases, my recommendation is even though questions A and B both involve a product where you're multiplying two things together, that it is easier to simplify and then use the power rule. Easier to simplify, use the power rule, definitely here. And for this last one, I'm kind of 50-50 on it, but I still think simplifying it to this will use the power rule much easier. So the question is, do we even need a rule for products and quotients? And the answer is yes. And here's a perfect example that I'm going to write over on the right side here. If I give you the function y equals sine of x times e to the x. In this particular example, I cannot do any sort of algebraic simplification to turn this into a single term and then use our current rules to take the derivative. This is a product. It must remain a product. And so we need a rule of how we deal with products. So the best way to interpret the rule for this, which is what I'm going to focus on, is to look at this as an area. If I want to find the derivative, we're going to call it, let's say, y of x, okay? And it's going to be a function f of x, say like sine of x, times g of x, again like e of x. We can interpret that y of x can be written as an area model of f of x times g of x. Now, as we look through the rest of these visuals here that I have provided in your notes, rather than have me talk about it, there's a really good video on YouTube that I am a huge fan of that explains this really well. So looking through this is actually the proof of it down here. To help make more sense of this, what I would advise you to do right now is pause my video and click on this hyperlink down here at the bottom, this YouTube video right here. The teacher in this video, I think, does a really good job, the best job that I've found of somebody who can explain this rule to you. So not mandatory to be successful at this, but always knowing why something worked does always help you learn something a little better. So my advice, pause right now, check that video out, and then return to my video for some examples. So here is the official product rule, okay? The product rule says that when you are going to take the derivative of two distinct things, what you must do is you have one that's called f of x and you have one that's called g of x. And what you're going to do is you're going to create a sum of two different things. The first sum is going to be the original f of x unchanged times the derivative of g of x. And then you're going to add it to the regular g of x times the derivative of the f of x. Okay, I should have been yellow technically if I was, instead of me editing this, I'm just going to watch me fix my mistake here. So f prime of x. Now, we need to figure out how we're going to remember this a little bit easier. So I have a couple pieces of advice here. So a way to remember the product rule is that you have two things called u and another thing called v. So the derivative of u times v can be u times dv plus v times du. So you can say u, and it's d meaning derivative, plus v du. I have another way of thinking about it. When you're looking at a product of two things, you have a term, a factor that is on the left and a factor that's on the right. So one way that I use to help me memorize this is that when I have two terms, I have a left term and I have a right term. And what I'm going to do is I'm going to take the left derivative of right plus the right plus the derivative of left. So I say to myself, left d right plus right d left. And so saying that to yourself enough times, in time, will make this a little bit easier to remember when you're doing different derivatives. So let's try a couple examples. We're actually going to start with the two examples. This was question A and question B from the warm-up. So this was A, this was B. I'd like to again make one more claim that for both of these, I would not actually use the product rule. And the reason why is it's easier to use the power rule. So I'm going to do this with the product rule just to show you that it does work. So we have two terms. We have x cubed, which is my left term. We have x to the fifth, which is my right term. And so our new rule says that when you want to take the derivative, you're going to write the left term times the derivative of the right term plus the right term, x to the fifth, times the derivative of the left term, which is 3x squared. Now, From here, we can do now a little bit of simplifying. And so by doing that, we're going to get 5x to the 7th plus 3x to the 7th, which is going to give me my f prime of x final answer as 8x to the 7th, which is the exact same answer that we got from our warm-up. Trying with example B. We have our left term, which is 3x plus 1. We have our right term, which is 4x plus 1. So by taking our derivative here, we're going to do g prime of x, that is. It's going to be left d right plus right d left. And once again, you do a little bit of simplifying here. And so we're going to get 12x minus 4 plus 12x plus 3. And so g prime of x is going to be equal to x minus 1 here. 24x minus 1, which is, again, is the same answer that we have. Now, these are two examples that I would not use the product rule in real life. Power rule is much easier. So let's look at a couple examples where we have to use the product rule. We have no other choice. And that's these two additional examples. So looking at the first one here, 5x cubed times sine x. Same process as we've done before. Identify your left term. Identify your right term. So left and then right. So now we can kind of say that power product rule to ourselves. So it's going to be left times d right, so that's cosine x, plus right times derivative of left, and that's 15x squared. There's not going to be much for you to do simplify this. Pretty much, I'm going to probably just leave it like this. Typically, we like to front of the trig function, so maybe I write 15x squared in front of sine x, but that's not really a huge deal. One big question that you might have as you practice these is, how much simplifying do I actually have to do? And the answer to that is, my recommendation is, don't ever leave negative exponents, and don't leave any complex fractions in your answers. Besides that, simplification is kind of up to the need of what you need to do. Once we get into some analysis where we do tangent lines and things like that, you'll see kind of how simplified do you need things to be. So this is our final example for this first video. And this is a problem where we have a product rule over here. We have a left term that's 5e to the x. We have a right term that is cosine x. But what makes this problem different than all the other ones that we have is we have this square root of x in front. Okay? And remember that when you take the derivative of a sum, you can take the individual derivatives of the sum. So I'm going to take the derivative of square root of x like I normally would. Then I'm going to do my entire new product rule over here, and I'm just going to connect those two answers with a plus. So square root of x, just as for the record, is x to the 1/2. And so when I take that derivative, I'm going to get 1/2 x to the negative 1. We'll simplify that in a moment. Then I have my plus, and then over here, now I get to use my product rule. So left d right plus right d left. So left d right, so that's negative sign. Let's watch our signs. Left d right plus, and then we have our right d left. In this case, that's just going to be 5e to the x. E to the x's derivative is, of course, itself. So in terms of simplifying this answer, first off, make sure you write y prime in front here. When I write this final answer, I can now write this as 1 over 2 square root of x. I would then go minus 5e to the x sine x plus 5e to the x cosine x. Once again, as I mentioned before, there's not really anything we can do to simplify this. There's no identity or anything like that that's going to make this simpler. So for this sake, I'm just going to leave it like this. And so here are 4 examples in total of using the product rule. So I'd like you to take some time now to go back, watch any parts of this video that you might miss, or things that might have been confusing to you, and then take a look at some of the practice problems that I have assigned for you. Good luck with the work.